Hello everyone, we're going to take a look at our Station 2 independent practice, practicing with symmetry and even odd functions. Okay, so we'll take a look at these three graphs first. And if we look at this first graph, you can kind of see it folds across the x-axis right here. Okay, and so you have this point 2, 2, and 2, negative 2. Okay, so this has x-axis symmetry. Now, note that x-axis symmetry does not go with either being an even or odd function. So this function is actually neither even nor odd. So a key thing to remember is that functions that are even carry y-axis symmetry, and functions that are odd carry origin symmetry, okay? So those two concepts just go hand in hand. So just remember odd is going to be origin, and even will be y-axis symmetry. Okay, so if you remember those two, it will help you always get them correct. Okay, let's take a look at our second graph though. So here on the second graph, let's match up a couple of points. How about these two? We got -1, -1, and 1, -1. Okay, so notice I have the same y value. This has symmetry across that axis right here. Okay, so we are symmetrical across the y-axis. Okay, so this has y-axis symmetry, and I would describe this function as being an even function. Okay, remember those two vocab terms just go together: y-axis symmetry and an even function. Okay, so y-axis symmetry is the type of symmetry associated with even functions. All right, let's take a look at the third graph. And now this one is kind of a tricky one. You'll notice it is an ellipse, which is the math term for an oval. Okay, and let's match up a couple of points on here. Let's do these, and I know the picture is not the best, so we'll just follow it as best we can. -2, 4, and then we also have another -2 point. -2, -4, and then maybe 2, 4, and 2, -4. Okay, so what you're going to notice is that you can actually fold this, you can match points up across all of these axes, right? So across the x-axis, if we were looking right here along the x-axis, you can see that this point right here and this point right here, the top and bottom points can match up, okay? We can match it across the y-axis as well. We can match up the points that are across from each other this way. Okay, so with that in mind, we can also do the origin symmetry, which means I should have points across from each other right here, 2, 4, and -2, -4, that are perfect negatives of each other. Okay, so what you'll see is that this actually has symmetry from all three axes or setups. So we have x-axis symmetry, y-axis symmetry, and we have origin symmetry. Okay, so three types of symmetry, and this function, most interestingly, is both even and odd. Okay, because it has both origin and y-axis symmetry, so it gains both of those descriptors with it. And so again, this graph is super interesting. It's got all these different symmetries. It's kind of showing you that a relationship or graph can have all kinds of symmetries on here. Okay, make sure you're always checking for all of them. Okay, all right, let's look at the more interesting stuff now. Okay, let's take a look at 4 and 5, where our relation is presented as a equation or in function notation, and we are trying to see what kind of symmetry this might have. Okay, so this is problem 4, and I just wrote it here to make a little more room for us. Now, if we're going to test this for our symmetry types, remember, we're going to plug in each different variable as its opposite and we're going to try and compare that to this original function. If it matches, then we can say that it has symmetry. Okay, so this is kind of how I would set this up. Okay, I'm going to go ahead and make a little bit of a t-chart, and let's start with our x-axis symmetry. Okay, and whatever axis you are testing, you will always plug in the opposite variable. So I'm going to plug in negative y. Okay, so I always note this. I say I'm doing an x-axis test, and then I'm going to plug in negative y. So here's what my equation looks like now. X squared plus x minus, and I'm replacing this, negative y is equal to 6. And very quickly, if I simplify this just a little bit, you will discover that this is not the same as the original, right? You will see that there's a big difference here, which is this plus sign, okay? That is not the same as the original. Therefore, this symmetry does not work, okay? No, not x-axis symmetrical, okay? So now let's go ahead and test the next one. So let's do our y-axis test, okay? Which means, again, we're going to plug in the opposite variable, which is negative x, okay? So negative x squared, okay, being careful with that parentheses here, plus negative x, okay, minus y is equal to 6. And let's simplify this just a little bit. Now, this negative is super important. When you square a negative, it gets canceled out. Plus minus, let's make that a minus x minus y is equal to 6. So you will notice this one has a few key differences from our original as well. This middle part right here is negative, okay? Which means that this is, of course, also not going to work. So there is not y-axis symmetry either, okay? And finally, let's do our origin symmetry. And origin symmetry involves using both of these. Okay, so we're going to plug in both negative x and negative y this time. All right, so let's see what happens. We kind of already know some of the behaviors from the first two times we did this, so it should be pretty quick. All right, negative x squared plus negative x minus negative y. So we know that this first sign is going to get canceled. We have x squared. This will become minus x. These two cancel, and we get plus y is equal to 6. And again, now you'll notice still got some differences here, right? These are not what I wanted in the original. Okay, so again, no match here, so this is not origin symmetry. Now, one of the main things we also got from this is that this function is neither even nor is it odd, okay? So conclusions we were able to reach. It has none of these three types of symmetry, and it is not an even nor is it an odd function, okay? So in this case, whenever you plugged in the opposite variable, you were not able to get any of them to be the same, okay? Let's check out number 5 as well, and we're going to test it the same way. Okay, so here we are. Let's test out number 5 as well. So number 5 is x squared minus y squared equals to 4. And we're going to run our test the same way. So let's make our 3-column test. So first column, let's test our x-axis. Then we can do y-axis. And finally, we'll do our origin test. Okay. So let's check this out. Our x-axis test, what do we want to plug in? We're going to plug in, of course, negative y, the opposite variable to the axis we're testing. Okay, so here we go. X squared minus negative y squared equals 4. Okay, be careful, guys. Make sure you're putting parentheses around this. It will save you a lot of grief in the long run. Okay, now this negative is going to get canceled by the square. So I have this x squared minus y squared equals 4. And lo and behold, this is a perfect match to what we started with, okay? And so what that means is we can come to a conclusion here that we have x-axis symmetry. Okay, put a little check mark so we remember that one's good. Okay, let's try out the y-axis. So now that we've got that, let's say y-axis, let's plug in negative x. Okay, so if we plug in negative x, our setup looks like this. Negative x squared minus y squared equals to 4. And again, we see a square with that negative, which is going to get rid of it. Equals to 4. And again, you're like, hey, look, that's a perfect match to the original function. Okay, put a little dot there. And we've got y-axis symmetry. And while we got this conclusion, I'm going to go ahead and say that since I have this y-axis symmetry, we can also say this function is even. Okay, remember, these both go hand in hand. So if you have this, you also have the fact that this function is even. Okay, so put a little check mark to remind us that that one's good. And finally, origin symmetry, right? So origin symmetry involves both negatives, negative y and negative x. Let's go ahead and plug them in. Negative x squared minus negative y squared equals 4. Now, you've heard me say this a couple of times already. These inside the square negatives are going to get canceled out. X squared minus y squared equals to 4. That's, again, same as original, right? So we discover this has origin symmetry. Okay, and what does that mean about my function? It is an odd function. Okay, so we discovered this has all three types of symmetry, x-axis, y-axis, and origin, and it is both an even and an odd function. Remember, guys, when you test these, just make sure you're testing all three, x-axis, y-axis, origin. And if you get either the y-axis or the origin, make sure you state that your function is even or odd as well, okay? Just remember, those vocab words go together. If you have y-axis symmetry, you are an even function. If you have origin symmetry, you are an odd function, okay? So good luck and happy studying.